Okay.
I shared it so much that somebody told me to stop sharing, which I thought was kind of funny. They were like, "You're
Did
too
you tell
generous."
him
Oversharing.
Sharing is caring.
Okay. All right, we should be live. Just check that a second.
It says we're live. Shows me as live.
We are live.
We are alive.
We are live.
Okay, we're live. We're live.
Okay.
All right, let's give the folks out there. Hey everybody, let's give the folks out there a minute to get on, and give me a minute to get on my phone. This is exciting. This is going to be a great. What is our Friday video called, Rich? Product. We don't have a fancy. Do we have a fancy name for Friday's video?
No, we don't do fancy.
Whoa. You have to come and see what we actually talk about, and then they get what then the fancy comes out. All right, I'm gonna try to find us live online. Matt said we're live, but I'm not seeing it. Let's see. But people are watching. Once I can see it on my phone, we can start. Is that cool?
Yeah, I think anytime you guys want to start, we're good.
You can see it?
Yeah, we've got some viewers and.
Okay, hold on. Give me 1 second. Let me just try to open it up on Facebook on my phone. Hey, there we go. Okay. Sorry, Rich.
You're okay.
So
I'm just sharing it around.
Okay, we're gonna start. We're gonna start here in a second, folks. Phones are so funny. Things that should be links are not links, and you just touch your screen over and over. Okay, we'll do that later. Let's begin. Hey everybody, I'm Kurt Altruek with MusicMedic, and today we have a cool special guest on our apparently unnamed Friday show, which is our product, which we call the product show. But and so this is a day that we talk about products that we have, or products that we sell, or products that we make. And in this case, it's a product that we want to talk about that is made by a super cool dude that we import. And so today's guest, who's going to tell us about himself, is Dr. Andreas Keller, who we call Andy. And Andy is going to share his he's going to share his story, so I'm not going to take too long to introduce him. I hope he'll tell us some of his cool story, but if I put his story into a 1 second nutshell, it would be a musical instrument maker / repairer met a materials scientist, and the two of them came together, and from that was born a company in 2009 that makes carbon fiber, all kinds of cool carbon fiber stuff, bells for trumpets and saxophone necks and cool stuff. And they put it on their own instruments, and it's made in Switzerland. And you can buy a trumpet that's made in Switzerland with a cool carbon fiber bell. Or if you're in America, you can just go ahead and order up a carbon fiber daCarbo neck from MusicMedic.com. So without further ado, I am going to introduce Andy. And Andy, will you tell us some about yourself?
Yeah, hi everybody. So thank you very much for this kind introduction, Kurt. I see you're well informed, so I don't have to tell too much anymore.
Oh no, we want to hear it.
No, but maybe I'll tell something about my person, because then you understand how this product was designed and how it came to a whole bunch of wind instruments made from carbon fiber composites. So many people think that I'm an instrument maker, but as you already told, I'm not. I'm a material scientist. So, and I worked, let's say 7 years, I worked in the scientific field, and in the scientific field of composite materials. And after that period, I got a job as head of an R&D department in the industrial field. And what we did there, we did noise reduction in loud machine parts. That's how I came into acoustics. And we always used composite materials to reduce vibrating part, vibrations in parts of the instrument, of the of the machines.
Yeah.
And why do you use composite materials? That for the thing is, the composite, the plastic composite materials like carbon fiber composites, the rigidity of a part is driven mostly by the properties of the fiber, and the weight of the part is driven by the wall thickness, and this is completely independent. So I can take any composite part like an alto neck here.
Look at that.
And for every single spot of this neck, I can choose mass and rigidity completely independently. So I can make it stiffer without adding weight. I can make it heavier without adding stiffness. So, and that gives me more freedom in acoustic design, because these are the two most important acoustic parameters. And that's what we did in machine parts. And I play the trumpet since my childhood and learned to play trombone. Later on, I can make 2 or 3 tones on a saxophone as well. And so that's, all of a sudden I came up with the idea to use this knowledge for optimizing wind instruments. But of course, I wasn't able to build a wind instrument, so that makes no sense if I'd do it, because I'd had to catch up 500 years of experience and development. So I was looking for somebody who can fulfill this part of the story. And this took me more than a year to find the right person, and I found it in Werner Spiri. Werner Spiri is my founder partner of the company daCarbo. And the special thing was, I was at his workshop, and we talked about trumpets. He is a trumpet manufacturer since more than 30 years and running several repair stores for wind instruments in Switzerland and music stores. So he has a lot of deep experience for high-end wind instruments. And I just introduced the idea what I want to do, and it took just 10 minutes. And he said, okay, let's do that. 2 weeks later, we already founded the company. So wow. that was really fast with him. But then it took us 2 years to develop the first instrument. So that was, let's say, it's three things you have to develop in parallel. It's the instrument itself, so that with the new situation, that was a trumpet, the first instrument. So with the new situation, with a completely different bell, so you don't have just to develop the bell and the acoustics of the bell, but it's also a new situation with this bell on a trumpet. So you have also to develop on the trumpet side. And that took almost 2 years to get a really professional instrument. And then you have to develop a manufacturing process. So it's not so easy to make complex shaped parts like instrument parts, which have to have a nice outside surface, but a very precise inside surface. So that's there is no efficient serial production process so we had to develop this process as well. And the third thing is you have to develop the market. If you have a good product and nobody knows about, that doesn't help. So all these 3 things took us 2 years in parallel before we started on the market. That was on MusicMesse in Frankfurt, 2011. So that was the start with one single trumpet model. And yeah, in the meantime, we developed a new model or even a new instrument almost every year. So we have a whole bunch of instruments, different trumpets, a whole bunch of trombones. We have the alto and tenor sax necks. We have a flugelhorn, so that the portfolio grew very fast. And we have been faster and faster in developing instruments profiting from the experience we made with the instruments we developed before. So I would say we are the number one knowledge base regarding composite materials in wind instruments, and that's somehow the goal to stay there and be on the top of this development for forever, for the future.
That's a cool. Go ahead.
Sorry,
Go ahead,
Kurt.
Rick.
Andy, we have a question from our audience. Just as you were talking about your development process, and we haven't really gone into how you manufacture, but already people are asking, how is it possible to make a bell for a saxophone in some way out of carbon fiber?
Yes, of course it is possible, and we even hold a patent that for. So that means it's possible for us. If anybody else would do it, he has to talk to me before. If he sells it regularly on a market, if he does it by himself, no problem. Everybody can do that. But if you want to sell it in a appropriate scale, so you need to go over me for that for. But we did not do it so far because there are a lot of other things to do. And what I personally think for the saxophone, the most efficient part where you can change the most is the neck. Of course, also the mouthpiece, but that's very, very individual. And but the neck is a part that is not too heavy. It's quite free vibrating. The saxophone body itself is very stiff because of all these mechanics on it, and very heavy also because of all these mechanics soldered on the body. And there is not too much vibration in the body itself, but a lot of vibration in the neck. So if you want to change something in the saxophone, it's most efficient if you do it at the neck. Maybe I have to explain something because there is always some misunderstanding. What you hear when you hear the sound of a wind instrument, that's not the vibration of the instrument itself. What you hear is the vibration of the air column that is surrounded by the instrument. So that means the material itself has an effect, but it has a minor effect on the sound. The main effect on the sound is the shape of the air column. So how is the bore progression in your horn and in your neck? And then the vibrating air column inside your instrument starts pushing against the walls, and the walls begin to vibrate as well. You don't hear the vibration of the walls. It's too low amplitude, it's the wrong frequencies, but it has some kind of a back effect on the air column itself. So it can modulate the air column. And here you can play with, if you can adjust acoustic parameters in a part, you can play with that. And that's this kind of physics is good for us because we don't change too much if you change material. So you won't have a completely differently sounding instrument. If you had a differently sounding instrument, completely different, you wouldn't find a market for it because nobody wants to play a saxophone that sounds like a flute or like something we do not know. So there has to be maintained a certain tradition in the sound, and luckily it's like that. So we can play around with the material without destroying the characteristics of the instruments. But what we do, I always say, we are an energy saving company. So we save your energy because we avoid vibrations in these parts. That means the energy stays inside the air column, and that has several effects. We may talk about the effects later. But That's our main goal, to get rid of instrument wall vibrations in those parts. And most of the energy which is lost in a saxophone is already lost in the neck before it's even in your horn. And we avoid this. So you need less energy for the same effect playing it. And many other effects, of course.
I've heard that a lot from our customers, that the response is one of the things that they notice to be like very dramatic when they play. That, you know, they have their standard neck, and although the sound is, like you said, similar, the response is,
Yeah.
I mean, from my experience, it's kind of incredible how much more response you can have from the material change.
Yeah.
We have another question from the audience. They're just curious about the possibility of a baritone neck, or even the upper branch on baritone saxophone.
Yeah. There has been a lot of times I was thinking about that. One of the problems is not on the technical side. You sell much less baritone necks than you sell alto or tenor necks. And our tooling to do these parts in the precision we want to have them, so that we have a consistency. And if you tested one at NAMM show, you will get exactly the same result if we ship you another one. So so those tools are quite expensive, and I haven't found a good financial model yet to do baritone necks. But I guess as we grow, there is also more financial playground, and there will be the day for sure we will do it. Yeah.
Very cool.
Yeah.
Nice.
Yeah, especially in baritone, I think the effect would be huge. Yeah. And baritone, we also can talk about bells, because for another reason, we can save weight. That's not so important for an alto, but for a baritone. So if you have your 20 pounds around your neck, so and you have to play a 2 hours show, maybe you would love it if it was just let's say 3-4 pounds lighter.
Yeah, that's a great idea. A baritone bell, a low A baritone bell would make it really accessible to younger people that had to carry that, or or just anyone that has to carry it around.
True.
So I have a question about your neck, the process. Like you in explaining your design of the neck, you were talking about kind of just changing the material, and that you have this control over it. So I guess in summary, are you saying that are you trying to stick with a certain inside dimension that comes with a neck that you know of, and then you change the material and adjust it from there, or and that's what you're doing, right?
Yeah. So I'm sure you know, but maybe not everybody knows. I would say at least 80%, maybe 90% of the saxophones are somehow developed from a base like a Selmer saxophone, like maybe even like a Selmer Mark 6. So everybody starts from there, or the main part of the manufacturer starts from there, which is again an advantage for us, because if we do a neck which fits to a Selmer Mark 6, we know that will work with the Yamaha horns, it will work with the Yanagisawa horns, it will work with 80% of the saxophones. There are some specialties where it does not work, where intonation is gone if you use our neck, but that's mainly vintage saxophones or from very small, very special manufacturers. But the mainstream horns, let's say mainstream horns, our necks fit. And what we did of course we did the same. So I took for both of the necks, I took a Mark 6 to start, and we just copied the inside shape in the beginning. But then we have some possibilities with this material, because we can really absolutely freely shape it. And what you do if you make it in brass, so you do the shape of the taper on a mandrel which is straight, and after that you bend it, and while bending it you change the cross section. Even if you of course you fill it with something and bend it down, but still you change the cross section. So that's in the original necks. The cross sections at every spot are not round, and ours is round inside, a perfect circle. But the cross section area is the same as in a Mark 6. So I think we took out some of these inconsistencies you have in a traditionally manufactured neck, which doesn't have to be. I don't say a Mark 6 neck is not good. Of course, they're good, because they take this into account, and they did try and error to find the right thing. But we just thought if we do it in a kind of scientifically perfect shape. And
you think that's what gives the neck the improved response?
No, this comes from the missing vibrations. So no vibrations in the material means the energy stays inside, and this has several effects. The modulation of the sound wave is the same in every frequency. So if you play the low notes or the high notes, the modulation is the same. That means the characteristics of your tone will stay the same. So it's very even, which is not the case with a neck that vibrates. Because these vibrations are different for every frequency. So the modulation is different. So your sound will change in the different registers. So that's one of the effects. The other effect is if you need less energy to start a tone, this tone will also start faster. And that's maybe what you mean with the good response. So you can, or no, what you mean with the good response maybe is also you can play more outside of the center of a tone. Still, there is enough energy where it has to be to start the tone. That means you don't have to be as precise to have a sound. And if the sound is once there in a millisecond, it starts supporting itself. And this whole process is faster. And that's what you mean with it has a good response. And in the same time, it also improves flexibility. So you can change your sound, you can change intonation much easier than you do with a traditional neck, because you don't have to fear that the tone breaks off. It's always, it needs so little energy to start the tone that you don't have to fear. And there is a very special effect about that. So you start realizing that when you play just 5 minutes, and then you don't fear your horn anymore. So you start playing more relaxed. That's a psychological effect, and it gives you more energy for what you're doing for the music, because you don't have to think about all these technical things. And the funny thing is, well, we observed that with many players, not just saxophone, also trombone and trumpet players. So after 3 months playing on their new daCarbo instrument, they adapted their in a way so that they play more relaxed now also on another instrument. They adapted their playing to a more relaxed playing, and they can do it on another instrument now as well. So that somehow this teaches people how to play. It's only psychology. Of course, there is a reason for, as I explained before, but the main effect is you feel confident. That's the main effect.
Wow, that's cool. That's cool. Thank you for that explanation. Are you going to show us some of how you manufacture these instruments, or?
Yeah, I
Can
can show something. Let me start. Maybe I have some raw materials here. So this, what you see here, is a carbon fiber thread. And this is not just one thread, it's 1,000 threads put together. And that looks like this. And it's very stiff. It's 8 times stiffer than steel. So, but
Wow.
But it has almost, it's very light compared, and as the fibers are so thin, I think 200 times smaller than your hair, that makes them flexible, so you can use it as a textile. And that's what we do. So those, you can weave it or you can braid it. In our case, it's braided. So that's braided such fibers. So it's a hose. So you can, do you see that? So it's still flexible. But what we then do, we have a mandrel, which has exactly the shape of the inside of a neck or of a trumpet bell. And then if this was the mandrel, so this hose goes over the mandrel like this. And we have several layers. It's up to 6 layers and different kinds of braiding material, different fiber directions. So we can control not only fiber volume content, we also can control the fiber direction. And the whole thing then is put into a completely closed tool. And so then you have the gap between the mandrel and the outer tool is exactly where the neck is in the end. And then we inject a low viscosity epoxy resin, which cures inside there. And then you have a problem. So you take it out. So now the core is still inside. How do I get the core out? And that's, we use a metal alloy for cores with a low melting point, so lower than 100 centigrades. So it's 96 centigrade. That's just below the boiling point of water. And in the end, that goes in an oven and the core melts away. And yeah, that's how it's done. I may show you some pictures. Let me see if I find here something I can show you.
I would have thought you would use a multiple piece mandrel and unscrew it.
No.
Yeah.
Let me see if I can show you
And while Andy's bringing that up, guys, we've had some other comments from the viewers who have also reinforced what Andy was saying about response and the energy of creating a tone, and that it's working well with even younger players. And then after we see some more about the manufacturing, we could talk about the possibility of maintenance or repair. That's just another question that I got from the viewers.
Oh, here I am. You should see this.
Yep.
So that's the tool where we cast the mandrel for a trumpet in.
It's a nice looking. What is that called? It's a nice looking tooling.
Yeah. So it's horizontal now, but if it's used, it's vertical, and that's where the liquid metal comes in and goes here and fills the bell, the trumpet bell. And that's for every single trumpet bell, we make a new mandrel. But the material can be reused, so there is no loss of material. And let me show you some. I show you that with trumpets. I don't have the good pictures for sax next, but it's exactly the same. So that's now, the inside is the mandrel, and that's how we apply those braided fibers on the mandrel. And here you see, yeah, here you see it. That's a mandrel for one of the trumpets without the crook. And
Is the mandrel the whole thing? Is that all going to melt out, or
no,
is that
no?
That's not melting out. That one you're just pulling out, right?
That one is not melting, and
that's a solid mandrel.
Yeah, but here, this part inside, this one is melting from here to here. That's melting, and this one is also solid from here. And here you see in the background, you see the tool, the outside tool. So this whole thing here goes inside here, and that's the upper part. So this comes on top of this, and then you have, then you inject from this side. We don't see it here, but from this side, the resin is injected, and there is also vacuum. So it's first you put it on the vacuum so that you don't have air bubbles inside in the end. Then you inject the resin, and then you heat up the whole tool to cure the resin. So that's quite, you can imagine that's the tooling is much more than you need for traditional trumpet making. But on the other hand, you don't have these manual influences. So every single part is the same. Yeah.
Wow, thanks for sharing that. That's really what, and
to understand what you're doing.
No, that's great, and that's sort of your factory there, right? I mean, that, and that's where you're right, where you're making them. It looks so clean and nice.
Yeah, yeah, that's how we work. Yeah.
Yeah.
That's great. Rich, you were going to show us one of the finish next, right?
Yep, I got one here. Let me just unpin this real quick. I've got one right here. This is let's see. Let me put me up here. I'm going to pin myself for a second. So this is the alto neck. And then I just wanted everybody, so there's your, and I wanted to show you guys, if we could talk a little bit about the removable tenon and how you fix the upper portion, how you fix the key as well to the carbon fiber too.
Yeah. Okay. So the clue, of course, is that this is unscrewable. So because even if I told you all the saxophones are copies of Selmer saxophones, they still have small differences in the diameter of the tenon. But even Selmer saxophones do not have even the same model doesn't have the same diameter all the time. So there is a way a technician can adjust this within a certain limit, but you can adjust this with your technician. But we also have the neck comes with 2 different tenons which fit most of the saxophones. So that's screwed. You can screw it back and exchange it to another. If your saxophone is too far away from what we deliver, there is whether your sax technician is able to do a part for you, or we also can deliver him or you directly special sizes. So that's no big issue, but let's say 70-80% of the saxophones fit with one of the 2 tenons we ship it with. And now you imagine that this part here, is just glued, and is a high risk that it comes off because you have a lot of lever here if you have it in the saxophone and you grab around here. But we solved this. I can show it because this is not mounted yet. So inside it looks like that. It has a step here. Can you see it?
Yes.
Yeah.
Okay. So it has a step here. So and this part, this ring, has the opposite step inside here. So if I put it over from this side, it cannot come off. I cannot take it apart even if it's not glued. Of course, we still glue it so that it cannot turn, but the saxophone itself would work even like this if it's not glued, because if I put the tenon tears the ring down and there is a perfect contact and it's even sealed. It's sealing just on this surface here. That's a very even surface here, and you have the same surface here. So this is pushed against this, and you don't need any O-rings or anything. It's a perfect seal.
That's a great design. That's
So
great.
Design of the tenon, and then you asked also about this axis holder. This is screwed, so there is a hole. We drill a hole, and from the inside it's a very flat knot. It's like a hat-shaped knot, which is very flat from the inside, and it's screwed on it and glued in the same time. So we haven't had any failures of this. So that's it's no problem. Anyhow, I never got a neck back, so they're working. Yeah.
And I know that we've had, we've taken ours and plugged this in and in a leak tester that we have to test for any sort of air leaks, and it just reads a 0. It completely seals.
Yeah.
So that's awesome. We did have a question from
We do a very simple test in the manufacturing. I just close it with the hand here, and I sock here, and I see that the tongue holds. Then it's sealed. So and even if there is a very small leakage, you will feel it like that.
The other question, Andy, is you've never had a problem. I just wanted to see, I'm just going through the comments here. They're asking, is it easy to re-glue if the upper tenon ring comes off? What other questions? Is there a way to repair?
It doesn't come off. But even if it's not necessary that it is glued, it's still sealed. And of course, that also answers the question. It's easy to re-glue. Of course, just use standard epoxy glue, and that will work. We use an industrial grade epoxy glue, which has a higher heat resistance and a higher impact strength. So just to be on the safe side in the long term, because also 20 years later, it still should work. But if anybody has hypothetically a problem, just use standard epoxy glue. That works for these materials.
Yeah, I've never heard of any of our customers having any problems. They just love the way it responds, and the quality is excellent. That's awesome. Kurt, do you have any other questions for Andy? I went through my questions from our viewers. They're asking if a flute head joint is possible.
Now, I wonder if a whole instrument, I wonder when you're going to have when are we going to see some tone holes and some cool posts fitted onto a body with special brass inserts and the whole thing.
Yeah. A flute is in discussion since a long time. Maybe the next 5 years or so, one of the instruments we want to try to develop. We didn't do it the first 10 years, because there is a patent out there which doesn't allow it. But the patent expires, I think, this year. So we're free. Now we're free. We can do it. You can hold a technical patent for 20 years and then it expires. There is no way you can hold a technical patent longer. And this patent, that was some Scandinavian guy who holds the patent, but he never got on the market with this. But now we're free. We're free to do it. Yeah.
Cool. Well, that's great. It's great to see how you. It's great to see how you manufacture, and it's been great to see the response of our friends and our players and our customers when they try the neck, and they appreciate the response and the intonation of your necks. And we're not obviously selling the trumpet stuff, so we are sort of a step away from that. But it certainly is good to see your products in action and have them here to try them and again see our customers' response. And today was just great to get your overview and hear your story. And it's really great, Andy. It's great to see you and it's great to talk to you. And
yeah,
thank you so much for sharing your time.
Thank you very much.
Yeah. So
it was a pleasure. It was a pleasure for me. So it's my life. So I like to talk about it. I just love what I'm doing.
It's awesome. I hope you keep it up, and I hope that trade shows happen again, because I know we see each other all over the world at trade shows. Hopefully we'll another trade show will happen and we'll get together. But until then, we'll just continue to be on the internet. And I think I can just say thank you. Thanks for coming out, and thanks for doing this, and thanks for everybody out there that tuned in and checked it out for our Friday product video session. Today we obviously had Dr. Andreas Keller Andy from daCarbo Instruments, and we got to hear his story. So thanks so much, Andy. Thanks for coming out.
You're welcome. I have to thank as well.
Okay. All right, everybody.
Thank you, guys.
Bye-bye.